You're listening to the Things podcast, brought to you by the Things Industries.
Thomas from Meshtastic Solutions, thank you very much for making time available. You're really busy. I saw you at the booth. How is it going so far?
Grand, absolutely. Every time I walk over there while I was waiting for the slot here, someone else tangled me up in a conversation. That's really nice.
Don't forget to grab something for the lunch, right? Because
yes, I already did.
Okay,
yeah.
Good. And what's your impression so far? Good.
Excuse me?
What's your impression so far? Good.
Very good.
Okay,
yeah,
good.
very busy and a lot of interesting contacts. Yeah.
And what kind of people are here? Mostly students or system engineers or managers?
There are a few students here, especially in the afternoon, but most of them are professionals.
Yeah, that's also what I recognize. So you're here with Meshtastic Solutions. So Meshtastic is really hot. Can you say something about your company?
Yes, the company is actually much younger than the open source project, because Meshtastic is an open source project. We started in 2020, and last year we got approached more and more by professional entities for contracts, consulting, SLAs, and of course with an open source project you cannot provide this.
Yeah.
So the co-developers, they put their heads together and founded the company to provide for these additional requests. So it was not an initiative, it was a request by our users.
Okay, so still a lot of people don't know exactly what Meshtastic is. Can you shortly summarize what it is?
Yes, you all know LoRaWAN because
Everybody knows LoRaWAN.
because you wouldn't be here anyway otherwise. But we use the LoRa physical layer,
Yes.
and then we use the LoRaWAN protocol stack and put it completely aside. We eradicated that and put a peer-to-peer networking protocol on base of the physical LoRa modulation.
Okay.
So everything is different, starting with their own string version.
Okay. So we're using the public frequencies.
Yes.
What is it? 900 megahertz or 868? I think.
You can use 433 and 8680 Europe, and of course other parts of the world use other frequencies.
So you use 868, 433 or 868.
Yeah.
You've got this LoRa layer, which is a chirp modulation technology.
Yes, the physical layer.
A physical layer, and on top of that you've got Meshtastic, which is a sort of there's no central gateway anymore. I think things are hopping around, right?
You can use gateways, you can use repeaters, but you don't have to. If you have two Meshtastic devices, they will find each other and communicate with each other. Of course, then it's not a mesh because it's only two devices, but if the third device comes into the game, it's a mesh network. And they form an ad hoc network.
Oh, okay, for my network.
Yeah.
So when I've got multiple devices, the messages will hop around between the devices.
Yes.
So the device is the network.
Yeah.
Great. Okay. And how does it? What is the performance? How many hops can you make? What is the reach?
The hop count is limited by the firmware to 7 hop counts maximum.
Okay.
Most of the installations use 3, 4, 5 hops because when we simulate the traffic, we see that in a normal distributed mesh, if you don't have a sparse mesh, the 6th and 7th hops will just add to congestion and will not give you any more range.
Okay. And this is a sort of a open source project.
Yes, it's an open source project.
And you were asked to, and there was demand, so you started a company. And what are the typical questions asked? So what are people asking you? What is your?
There's no such thing as a typical question because there's a lot of beginner questions that are answered the same over and over again. And then there are a lot of specialized questions because people are telling us what their use case for the system would be. And then we say, okay, this will work, and how this will work or this will not work because this is too much bandwidth or
No streaming video, of course.
no streaming video, no audio. We can do audio only if we use 2.4 gigahertz LoRa chips. We can use them as well. It's not often used, but we can use them, and then we could even do audio over it. I'm not aware of any. I'm not aware of any inbuilt use cases.
Use it data for IoT, for small status.
Most of the stuff is text networking, position broadcast, telemetry, of all kinds of stuff. We have one guy in Austria measuring how heavy their beehives are.
Okay.
With it.
Okay, impressive.
Yeah. So they put a scale chip on it.
Okay.
And said, okay, today they made 500 grams of honey.
One bee leaving, another bee coming in. Okay. Okay. Amazing. And
So this is nothing any of us will have come up with. So these are really the users coming to us with their use cases.
Yeah. And which markets are taking this? Is it still sensor market or industrial or is it hobbyist still?
So geographic distribution is really worldwide. We have user groups in almost any country. And also, of course, the strong user base is hobbyists. We're using it while hiking, while paragliding, while driving on their bicycle, or with their car, doing the expeditions. But there's been increasing demand from the industry.
I saw people on Reddit taking pictures of sitting with the Meshtastic devices in the bus. Scanning for other devices, creating their thing.
And actually, a few weeks back, a commercial company put a gateway in Germany on the Zugspitze mountain.
Okay.
So this is in 2 weeks. It has now accumulated about 1,000 nodes in its database.
Okay, wow.
And it reaches beyond the north limits of Munich.
Okay, wow, amazing. So, other particular challenges with this technology?
Yes, of course, scaling.
Okay.
Because the default settings we're using are made for a long range and finding other devices in your area. When you first switch them on. But if you get to 50, 60, 70 nodes in your network, you need to switch to a faster preset because they will take up all of the airtime in this long preset we're using. So we're deliberately starting with slow broadcasts, but they will go a long way. And then if you have more and more people using it in an urban environment, you need to switch to different presets so you have more capacity in it. Okay. For instance, at Burning Man this year, we had a huge network with 2,500 people on it.
Okay, amazing.
Of course, this does not run on the default settings.
And Thomas, I'm just curious, if you compare this with Zigbee, Z-Wave, or BLE, what is the main difference?
All of those technologies are clamped to the 2.4 gigahertz range.
Okay.
With its advantages and disadvantages. So we can use any frequency range there is.
Okay.
Because the chips that are made by Semtech, you can get from, I think, 150 megahertz up to 3 gigahertz. So you can just tune them. It really depends on the application circuit, how you use it.
Somebody's listening and wants to start. What should they do?
Contact us.
Okay, mail, email, website.
Anyway, maybe even over Meshtastic.
Thomas Göttgens, they know how to find you. Thank you very much for making time available. Thank you. All the best. Danke.